Welcome. Today we're going to talk about chemical composition of living organisms. And first, let me give a background on biochemistry and the essence of life and what we are discussing chemical composition of living organisms. Biochemistry explains molecular events or the molecular events underlying biological processes. And this is first. Secondly, let's say functions. Biological. So biochemistry explains biological processes and functions all at the molecular level. So biochemistry addresses fundamental questions such as one, what distinguish living organisms from non-living organisms? The first one, let's say living organisms. Two, what are the unique atoms and molecules? Atoms, molecules that are exclusively found or related to life. So here, what distinguish living organisms from non-living? So living slash non-living. And what are unique atoms or molecules that are exclusive to life? By the end of this video, you will be able to explain the chemical basis of life and what makes living organism distinct from non-living matter. Secondly, you will be able to identify the bulk elements or elements essential to life and their roles. And thirdly, distinguish between bulk and trace element and their biological significance. Interestingly, both living organisms, for example, a human being, or an non-living matter, for example, a table, are composed of the same chemical element. Example, carbon, hydrogen, nitrogen, oxygen, we can go on, potassium, and so on. What set them apart is not which elements are present, but rather the relative abundance of these elements. And secondly, the specific ways in which they bond together. So what set the living organism and non-living organism apart is not which element is present, as I said. It is the abundance of these elements in the specific ways in which they are bonded together. Let's look at the element essential to life. There are about 90 natural or naturally occurring elements. These elements are found throughout the universe, including the earth crust and the atmosphere. Of these 90 or more than 90 natural occurring chemical elements, only about 30 are essential to life. Most biologically important elements have low atomic numbers. Only 5 are essential, or 5 essential elements. That is out of the 90, out of the 30, only 5 elements have atomic numbers higher than selenium. Selenium's atomic number is 34. So only about 5 of these essential elements have atomic numbers higher than selenium. They include molybdenum with atomic number 42. Next is tin with atomic number 50. Molybdenum is involved in enzyme catalysis, while tin is not essential for humans. It is important for some marine organisms. Next is iodine with atomic number of 53, crucial for thyroid hormone production. Next is tungsten with atomic number 74, used by some bacteria in redox reactions. The last one is lead, the atomic number 82. While not essential for humans, it is used by some organisms. These essential elements are generally grouped into two categories. As I've mentioned, we have about 30, about 30, including these having atomic number higher than that of selenium. So these 30 essential elements are grouped into two essential are grouped into two. First is the bulk element. The second, call it trace element. So let's look at bulk elements. Bulk elements are required by organisms in large amount. Typically grams per day. These elements serve as the structural component of cells, and tissues, and are involved in numerous biological reactions. They are also involved in several reactions. Example of these bulk elements: hydrogen, carbon, nitrogen, oxygen, phosphorus, sulfur, sodium, potassium, calcium, chlorine. These are examples. The four most abundant elements in the living organisms include carbon, hydrogen, nitrogen, and oxygen. Together, these four account for more than 95% of the human body. It means that you are made of just a few elements. Note that these values here on the table are approximate values because the composition of the human body can vary based on age, sex, and other factors. These elements are lightest or are capable of forming 1, 2, 3, and 4 double bond respectively. And the lighter atoms tend to form stronger and more stable bonds, which are crucial in maintaining the integrity of biomolecules. When you look at the composition of the earth crust, while oxygen is abundant in both the human body and the earth crust, other elements show stark contrast. For example, carbon, hydrogen, and nitrogen, though essential to life, are only present in trace amount in the earth crust. In contrast, silicon, aluminium, and iron are dominant in the earth crust, but not major component in living organisms, for example, the human body. This difference further illustrates that life is not about the uniqueness of elements, but about how ordinary elements are uniquely arranged in the living system. Let's look at trace elements. Trace elements are required in minute quantities, typically milligram or even microgram per day. However, they are indispensable for life. Examples, we have magnesium, iron, zinc, copper, manganese, selenium, iodine, and others. Though they make up less than 0.1% of the body mass, trace elements are vital for a number of functions in the body. For example, enzyme actions, they are important for enzymes. They serve as cofactors. They also are important for energy metabolism. Here, several participate in redox reaction, donating and accepting electrons. They are also important for the structural integrity. Some stabilize the structure of proteins and other biomolecules. They're also needed in, or they're useful in gene expression, and signaling. We've seen certain trace elements regulate receptor function, ion channels, and transcription of genes involved in vital processes. So, what can we learn from this information? What can we learn from chemical composition of living organisms? Chemical compositions of living organisms reveal a fascinating truth. I want to point it out. Life arises not from unique elements. That means both non-living matters and living organisms have similar or the same elements. But the difference comes from the precise and the purposeful arrangement of common elements. In other words, living organisms and non-living matters are not distinguished by the chemical elements. Living / non-living they are not distinguished by the chemical elements. No, that is the chemical elements they contain, but they are distinguished by the relative abundance of these elements and so biochemistry enables us to decode this design, revealing how the simplest atoms arrange in a way give rise to the complexity of living systems. In subsequent videos, we shall look at the connections these elements make with each other. So let's do some exercises. The first question is, which of the following statements best explain why living organisms are distinct from living matter? The first option is, living organisms contain special elements not found in non-living matter. B, living organisms are made entirely of radioactive elements. The same elements are found in both, but in different proportions and combination. D, non-living matter contain more organic compound than living organisms. The answer is C. The same elements are found in both living organisms and non-living matter. But the difference, or what distinguishes them, is the proportion of those elements and the combination they make, or the bonds they make with each other. Don't forget this. The second question is, which four elements make up over 95% of the weight of the human body? From the table we have studied earlier, we noted that the four elements include carbon, hydrogen, oxygen, and nitrogen are the four most abundant elements in the human body and form the structural basis of all biomolecules. Okay, the third question. Which of the following elements is most abundant in the earth crust but present in only small amount in living organisms? Again, remember our table. We the options here, we have A, carbon, hydrogen, silicon, and nitrogen. Yes, of course, oxygen is found in oxygen is not here, but we know oxygen is found in considerable amount both in the human body as well as in the earth's crust, although not the same quantity or amount, but considerable amount. The one that is very clear here, sorry, the one that is very clear here is the silicon. We noted that silicon is found in trace amount in human body, but is found in the earth crust 26%. So silicon is the element found in the earth crust that is amount present in large amount, but in human very small amount. So thank you for listening. See you next time.